treatment and local reuse for citywide sanitation and improved river health. We have received an overwhelming response, around 1,700 plus registrations from around 50 odd countries. A mix of registrations are there from government, non-government, academia, consultants. And our chief guest for today's webinar is Shri Rajiv Ranjan Mishraji, Director General, National Mission for Clean Ganga. The moderator and anchors are Dr. Suresh Kumar Rohela, who is the Senior Director and Academic Director, and along with him is my colleague Bitush Luthra, Program Manager. We have put an array of the eminent speakers and discussants who will be part of this webinar and sharing their experience. From here, I would request the course director as well as the academic director of CSE, Dr. Suresh Kumar Rohela, to take the webinar forward.
Thank you, Marine. I will share screen, a short presentation before I ask our chief guest. Very welcome to all the participants for this webinar, and a special thanks to Sri Rajiv Ranjan Mishraji for sparing time from his busy schedule. All the speakers who are connecting from different parts of the world, very, very welcome. And the participants and discussants, very welcome to all of you. I would take 2 minutes to just speak about before the agenda for this workshop is that basically CSE has a capacity building and, initiative under which we bring together policymakers, practitioners, and decision makers. And CSE also has been working with Namami Gange, National Mission Clean Ganga, and Ministry of Housing and Urban Affairs, CPHU, as one of the Center for Excellence. And we have been developing the agenda for urban water management over last decade or so. And this webinar is the 13th webinar in the series of webinars with School of Water and Waste, which is the capacity building initiative under CSE, which organizes for knowledge exchange and way forward to discuss with practitioners, policymakers. So a month ago, we had organized a webinar with National Mission Clean Ganga on importance and the need of fecal sludge management in river basin states in India. And we realized that there were also concerns that fecal sludge management is important, but then what happens to the liquid waste and the sewage, which remains untreated. So we thought that it would be timely to organize a national and international level experience sharing workshop, which is virtual workshop, to bring together experiences. And I would just share my slides. So is it okay, Marine? So can I go ahead?
Yes, sir.
Yeah. So this short presentation is today going to give you a background about CSC, saying CS 10-year journey. We have built a capacity of 5,000 practitioners and sensitized a community of practice over a decade or so. We have organized 82 events in India, South Asia, and Africa on this subject of decentralized wastewater treatment. We have done 60 technical trainings, tailor-made training programs. We have alumni across globe, 1,750 and 2,700 participants who have been sensitized. We have successfully running model projects, which we are monitoring regularly, CSC laboratory as well as pollution control boards. Some of these pictures, you would see that these are the functioning projects. This is the Delhi Jal Board headquarters, CSC head office. We have in Rishikesh, one of the model projects. You can see that these projects are there which have been treating sewage to the permissible standards of pollution control boards. This is a CSC training center where we have used soil biotechnology and planted filters. And we have Nehru Park in Alwar, where there is a public area where treated wastewater through natural treatment systems has been happening over a period of time. This is the recent project in an urban village in Delhi, where we have created a new knowledge saying that there are options available for decentralized level cost-effective measures where urban sanitation could be improved. So these are some examples where we thought that there is a need that we should put together. And CSC has put together a menu on unnetworked technology on-site sanitation systems called MOUNT. And I'm using today this webinar to request our chief guest to launch MOUNT. And Vitush, you can take after this 1 or 2 minutes to show what MOUNT is. And then we are also requesting after I stop speaking, for release of a handbook of operation and maintenance of these decentralized systems, because these systems do not have SCADA or automated systems like sewage treatment plants which are running over the city. But these systems also require management systems. So CSC team has worked on this, and we have developed these two outputs to further continue our advocacy and innovation in practice, and share learning with the community of practice across the world, and also mainstream this into India's leapfrogging towards how do we address the river health in Ganga Basin as well as across India. So Bitush, can I request you, I'll stop sharing the screen to show people the link of uh, Mount. And before I ask Rajiv Ranjan ji to formally inaugurate this. So Mount 2 is an exercise where we would be, this is a web-based portal which brings together various such successfully running projects. The phase 2 of this would have data of uh, people, technology provider, real beneficiaries, real implementers. Bitush, please go ahead.
Okay, so as you can see, went through cscindia.org and this tool called Mount. As Dr. Oila said, we have named it Menu on Unnetworked Technologies, which would mean that if you don't have a centralized sewage system, what are the possible solutions for you? So if I just drag it, I'll quickly go through it. So if we don't have a sewerage network, we are dependent on on-site systems. We are dependent on decentralized systems. And then if we are dependent on on-site systems, we should be doing fecal sludge management, as well as in situ treatment kind of finds its way when we don't have centralized systems. So we have given it 4 categories. And this particular web-based tool is actually giving you not only the technologies, it's giving you a lot of case studies on each of these. So if you go further down, so you could search by subtype of technology. There are subdivisions, there is capital cost, and the O&M cost. These filters are available. And then if you go through one particular sub-technology, you have case studies on the right. You can see some case studies all over India and beyond on those systems. So in this, apart from this, you could also search through this map. If you see, it is color-coded. If you're looking at the decentralized system, these are red tags. If you're looking at FSM case studies, you have yellow tags, similarly green and also on-site. So you could, if you want to have a look at in geographically how these technologies have been implemented throughout, you could go through this map as well. Having said that, there is another way you could search for technologies. These are sub-technologies. So red color denotes decentralized technology. You have DWATS, soil biotechnology, phytorid, so on and so forth. So if you move around this particular chart, you could see all these sub-technologies in these categories. So what is new in this? This is we are calling as Mount 2. We have added a lot of resources. There's glossary, there's FAQs, there's recommended readings. So I'll just maybe quickly show you. And also we have added list of implementers. So if you want to implement certain things in your respective cities, you would be wondering, where should I get anybody who knows about the system? So we have generated this list. This is not comprehensive right now, but we are going to grow on it. Apart from that, you have recommended reading material. And we keep on adding more stuff to it. So there is, so you can just have a look. All these papers and reports are actually referring to if you want to implement any solution which is not centralized. You have a lot of repository over here.
You can tell about the contribute thing, Bitush.
And then we have also videos. So if you want to kind of convince a decision maker, you could have a look at the videos available out here on site, FSM, decentralized solutions, or we have all the videos out here. And so also we have blogs. So I'm not going into the blogs right now, just because time is less. There is this button called contribute. So if you think that you have a technology, sub-technology, which is non-sewered, and we have not covered it yet. You can contribute using this template for technology, and you can also contribute if you have a case study that you have implemented. So there will be a review process, and once we go through that, and then we can of course add all your material over here. Similarly, you have a lot of other ways you could search technologies and case studies. So maybe I'll stop here and encourage you to go and visit this webpage.
Thank you, Bitush. Thank you. So Rajiv Ranjan ji, this is something which we want to submit to you as a part of our support to National Mission Clean Ganga and your efforts which you are doing, which will help achieve the goal of improving river health. And I'm sure that you would be happy to release this or start this mount. We have sent out some posters to some people. If you can formally release, sir, hold it up, these posters, to say this is officially released. So some of you people, we have given you this, sir, and before. So thank you very much. So today we are officially launching this, and we look forward that some of you would be able to submit case studies. And then I also take this opportunity to request you to, sir, launch this, release this handbook, which is a small handbook, sir. This handbook is used for those operators who run these systems during COVID and post-COVID, which is very important, because if it is a bullock cart or an aeroplane, both needs maintenance. So this handbook is pictorially displaying the importance for operation and maintenance in these systems. So with this, sir, I request you to say a few words to the participants, around 1,600 people joining from different parts of the world, and encourage us.
Thank you, Suresh. It was really very useful for me to be here and see the good work and the kind of innovative things you people are doing. I also see a lot of close friends and associates who work with us in the audience. Rakesh ji is there, several other people are there. See, we are all very much aware about the importance of managing water well, especially in the urban setting. We are also very much aware the way urbanization is taking place, it's going to become even more and more. And then in future, urbanization is going to be even more in Asian and African countries. India is also urbanizing, and our numbers are really huge. I mean, we are going to add huge numbers by 2030, and the state of water and the state of city, I think we have to really look at them both together. Often what happens, we look at different parts of our problem. We look at city improvement, but sometimes urban development does not look at development or protection of water bodies in the urban area. Often we give a lot of priority to the drinking water sector, but we really do not integrate and think or give same kind of priority for the wastewater management. So I think with all these kind of issues, ultimately we end up with a very unplanned way of managing water in the cities. The growth of cities, sometimes without proper planning, adds to our problem. As we all know, as the city keeps on growing, we have lots of peri-urban area. We have rural areas on the edges of the city, which ultimately become urbanized. So I think we have to think in terms of a continuum. We have to think in terms of a kind of system. The system has to consist of city. The system has to consist of a small towns, villages, and the river and other sources of water. And I especially value this discussion today, which we are doing, because ultimately we have to manage our water with more focus upon local solutions. I'm not only talking of the wastewater, even drinking water. I think if you really protect your water bodies, local water bodies, keep your rivers healthy, perhaps you don't have to transport at a huge cost drinking water from a different place. We are all aware we have certain drinking water schemes where the city which is on the bank of one river is trying to get water from another city. I mean, the Agra is an example. We have a huge drinking water scheme launched trying to get Ganga water to Agra, which is on the bank of Yamuna. So I think that shows us to prove that we have really not given importance to the local solutions, to the decentralized solutions, and that really brings to the fore what we are trying to achieve together with CSE. We have been working together. At the outset, I will also like to tell you, see, the life is not so simple. When you are looking at urbanization and then water management, we all know India has 18% of the population and 4% of the water resource, global water resource. So we have a lot more to be concerned of. So you have to look at a kind of a set of solutions, a mix of solutions. Only centralized way, the way we have been looking at our cities and looking at water management, has been a very typical sewage treatment plants, sewage network. And we are all aware how, I mean, in Namami Gange Mission, I can tell you, we have learned with our experience. We have actually constructed a large number of projects. We have constructed a large number of projects. We have also innovated. We have looked at O&M. That's why this guideline, which the small book which we released, the O&M of decentralized system, O&M is always important. As I told you, we always give priority to drinking water. We forget wastewater. Similarly, we also give priority to construction. We always give less priority to operation and maintenance, and that there lies our problem. So I think that is something which is very important to look at, and then we have to look at a solution, a mix of solution. We have to have some centralized system, we have to have some big system, but we'll also have to have decentralized system. We'll have to have the menu very rightly showed different way of looking at things, on-site, in situ, decentralized, fecal sludge management, several things. And actually, we have been trying to do what we tried to do in Namami Gange when we looked at the STPs and then the sewerage system. We tried to look at 15-year operation and maintenance. So the O&M is always on the back of our mind in Namami Gange Mission, that we must really think of. Our job should not be to construct, our job should be to maintain, to operate them, meet their standards, then only environment will improve. Just constructing something is not going to really help us. So that's why we tried to introduce hybrid annuity. We tried to improve some efficiency there. And then for last few years, last 2 years or so, we are working with you to also improve septage management, integrate that. So now what we have got centralized, bigger STPs. We have got, again, there can be a lot of dispute. What is centralized, what is decentralized? It all depends upon the scale. Then you have to have septage management. Then septage management, again, you have solutions. You have either a standalone FSSTP or you have port treatment. So port treatment brings a kind of midway between STP and septage management. It's a good option, good solution. And then decentralized wastewater treatment plants, for which today we are discussing in detail. And I can tell you from our experience, we have tried to experiment with bioremediation, phytoremediation. NEERI director is here. He has been helping us in several projects. During last year, Kumbh, we actually experimented with a lot of these technologies. See, when you try to scale up these technologies, the real challenge comes, you do not, first of all, you do not know what exactly is the most suited thing for your requirement. And that's where perhaps the need of having experts, the technology experts joining and then discussing it very important. Then from where you get standards, how you develop SOP, because see, it's not, as long as it's a pilot thing, it's very easy to do. But when you are trying to look at scaling it up, trying to really go for a much bigger solution, you will have to develop a kind of SOP, you will have to develop guidelines, you will have to develop the safety guidelines. I think I'm very, very happy to see one page on the COVID related precautions in this O&M also you have written. So I think we have to be live to all the challenges. And that's why a website or a web portal like this will be very useful. And you very rightly said that it's still not complete. See, things are never going to be perfect. But what's perhaps most important is today we are launching a portal where actually a lot of information is there. And then again, we really don't know whom to approach. We have a problem. First of all, we fail to identify our problem correctly. We simply jump to the solution. But suppose we are lucky and we have identified our problem correctly, then we will know who will solve our problem, who will help us, in what way, whether it's construction needs or O&M needs or a kind of designing the whole system. So you need lots of people to come forward and help you. So I think I'm very happy to see in that some good cases, some good works which has been done. So case studies are there. You are also trying to list the kind of agencies. I know the list will not be complete as of now, but as we grow, as we work together, the list will become bigger and more complete, and then really that will help us. So ultimately, I really congratulate all of you, and then I'm very sure that this meeting in which lots of technical people are there, senior experts are there, will develop a kind of framework, will also develop a kind of platform where perhaps we would meet more often, and then the experts will come together and develop some of these SOPs. We are having another meeting with CSC tomorrow, and then a lot of these things should come in our action plan for the next year or even beyond that. So it's a very good beginning. I'm nowadays very happy to see that people are talking more about water management, water conservation. There is a lot of dialogue, lot of talk going on about water. And when we are talking of water, everywhere we are trying to also bring in the discourse the wastewater management, solid waste management, and then septage and wastewater management together. We are trying to really work out a kind of good solution. It's also very important to look at decentralized thing, as I told you in the beginning, that the local solutions are important. Whether you want to drink water from the local source, only when you keep it healthy, you will be able to do it. Similarly, and then how the water sources will be healthy if you dispose of your wastewater correctly, or you dispose of all your waste correctly and in a scientific manner. So I think we will have to look at this entire cycle. We have to increasingly get into thinking of integrated urban water management, and in that we have to put river. If the city is lucky, actually we should consider city to be lucky if there is a river passing through that city, and then we must respect that river. We must look at its health, and we must see that we have received this river from some other city. It's going downstream. You must leave the river in a better state of health. If you cannot give better, at least leave it in the same state of health to the downstream cities. So we have to look at a kind of 2, 3, 4, 5 regional kind of city, and then start envisioning a bigger thing while trying to solve the problems, what is most appropriate for the local level, for the neighborhood, for the new township coming up. So that kind of culture, that kind of thinking is very important. I'm really, once again, I'm very happy and thankful to CSE for taking lead, and we are going to be with you. I see increasingly more number of partners joining these kind of discourse, and that's why perhaps that gives us a lot of hope that perhaps the time for seriously looking at water management has arrived, and then we would be really able to move together and then meet the goal, the SDG 2030, not only the goal number 6 and 11, but if we manage these things better, it will help India to achieve many other goals very effectively. Once again, thank you. I will have to take leave because I have a meeting with Honorable Minister shortly within few minutes. So I will leave, but my team from NMCG, many of them would continue to be in this discourse, and then we'll continue our discussions Suresh tomorrow. Thank you.
Thank you, sir. Thank you very much, sir. मैंने 5 लोगों को ये case studies वालों को बुलाया है presentation के लिए, and there is a group of 2 experts from Switzerland who have done detailed study of such systems. They will also be presenting here. We will be able to update you tomorrow when we meet, sir. Thank you very much, sir.
Okay. Thank you. Bye.
Sir, we will start now formally, with your permission, sir, the next session, which is the webinar. So thank you people for joining. We will now begin formally the webinar. Mehreen, you can take over from me. And this webinar is being organized in partnership with National Mission Clean Ganga and Swachh Bharat Mission, to whom Center for Science and Environment is helping and assisting in the process of mainstreaming reforms in the area of improved urban sanitation and improved river health. So with these 2 objectives, we are bringing together experts and real implementers and real beneficiaries of the projects. Some of the projects are listed in the mount. So Mehreen, please take it over. So
our first presenter for this webinar is Dr. Rakesh Kumar. He's the Director, CSIR, National Environmental Engineering Research Institute, called NEERI. He has a vast experience in all fields of environmental science and engineering, especially air pollution control and management, varying to environmental impact assessment. Dr. Kumar has given a notable contribution in developing technologies for reuse and recycle of domestic and industrial wastewater. He is expert member of more than 30 committees. And with this brief background, I would request Dr. Kumar to please share your experience with regard to the phytored technology. Over to you, sir.
So we would request all the speakers for 12 to 13 minutes, sir.
Right.
And we will. Yeah.
Thank you, Dr. Rohila and Mehreen, and I see Dr. Tyagi also there. Of course, Vishwaji has left, but there are a lot of people who are expert in this field and of interest. So welcome to all the people here. I'll just share my screen and then start representation. Okay, if my first slide is okay, then I'll assume it's going well.
Yeah, all well.
Thank you. So this is where we work at NEERI in Nagpur. That's what is our head office, but we are also there in 5 different cities in the country: Mumbai, Delhi, Kolkata, Chennai, Hyderabad, and but it's very interesting. I'll take a couple of minutes to tell you what this institute is all about. It started as Public Health Engineering Research Institute way back in 1958, and that time the whole mandate of the institute was to do work in water and sanitation. And the mandate we felt probably over a period of time will go away, but it looks like the way our population is increasing is not going to go away. So, but while we moved in public sanitation and water, we realized that there are many other things important. So industrial waste management, hazardous waste, solid waste. And that's how, since we got into every field of environment, the name of institute was changed to National Environmental Engineering Research Institute. So looking at the profile of the institute, we have more than 500 people who are scientists and technical engineers who work together to address any problem in a multidisciplinary fashion. In recent times, if you see the strength on the left-hand side, almost it covers all aspects of the environment. But some of the ones which are very important for us in recent times have been listed at the top, which were also important earlier. But we are also largely into eco-restoration of spoiled environment. And we are also working in the area of environmental materials, sustainable urban management. And now we have started a center, we call it strategic urban management, which looks at almost all aspects of environment, which is air, water, solid waste, energy, transportation, and everything else. So some of the work that has been going and that has been done, I'll talk about a couple of them, which is connected with the topic here. But besides that, in composting, we are there in common effluent treatment plant. NEERI is flood water management. Whenever the contamination happens, when flood situation takes place, we have a technology here. Phytored is a technology which we developed way back in 2005, which has been across the country now. We have electro-defluoridation, wherever we have fluoride-related issue in water and arsenic as well. We have plants which are decentralized, small ones, which can be used in villages. When we look at wastewater, specifically the topic of today, India, of course, has been generating, this is a number from CPCB, 66,000 MMD, but probably it's much more than that, because these numbers keep increasing as we increase our population. The very interesting part is that only 30% still gets treated despite having massive funding which has happened from the government side. Overall, when we look at these problems, it's very important to note that all centralized systems which have been placed in one of, I would say rather 3 reports which happened in 2003, 2009, 10, and again 15, 16, we find that most of the centralized systems have problem in country like ours, where we have power issues and other issues. So why are we looking at alternative system? A lot of people asked me as a director as well as a scientist earlier that why would NEERI get into small issues, because we were designed as an institution, we were designed to talk about centralized systems. But as we go ahead, we find that some of the centralized systems meant to be doing good in many parts of the country are unable to work because of power availability 24/7. So any mechanical system, if you have any failure for a limited period of time, the whole system collapses over a period of time. High operational maintenance cost, and of course, every time it needs technology updates and trained manpower. When we look at other side, some of the drains which are crisscrossing cities. In some of the cities in our country, we have more than almost 2,000 kilometers of drains, small and big together. So we have tried doing interception, diversion, and treatment, but whenever we do interception on the last point, we have created issues of the sewer movement. And as the time when the clogging happens over a period of time, then finally it is broken and the sewage finally flows into the river. So this has an idea is good, but hasn't really actually worked when we look at example of Kham River in Aurangabad. Nasik in Maharashtra, to you name it, some part of Ghaziabad and some other cities as well. Sewer conveyance and pumping systems, when we look at all of them together, sometimes just to collect sewage, our all money gets used. We don't have enough money left for having treatment plant and finally maintaining it. So what do we do? So we have done a lot of work in phytorate-based treatment plants. I'll not go into details, but relating to that, some work that we have been doing is in lake cleanup systems, where we are looking at a flow raft system, where we do floating plant nature-based systems, so that we can remove nutrients and the carbonaceous pollutants, so that it gets treated over a period of time. We have recently implemented a project in Raipur at Telibandha Lake. This is how the lake has been, and now it's in good shape. This whole project has given a lot of, I would say, positive vibes, not only to the people locally there, but as well as everyone else, that you can actually change our lake system that we have. I would like to create this caution that anytime when we say lake rejuvenation, the first step should be the lake should not get into a situation where it needs rejuvenation. So as long as we can maintain that, we are good. So after that, we got some award for doing all this. So lakes, very complex systems, and currently we are doing a master plan for all lakes of Bangalore city. We are doing a massive exercise for Delhi Jal Board as well, for most of the lakes in Delhi. Idea is that we must treat anything which is getting into the lake, and then also maintain the lake the way it is right now. So I wanted to highlight this technology, new one which we have come out with, and which was used in Kumbh Mela last time. We call it Renew, which is a combination of different ecological units, which actually treats the wastewater inside the drain itself. What it actually does is that we are avoiding the whole system of pumping it out, taking it to a centralized system, and then doing treatment. Of course, that is the ideal thing to do. But wherever we can't, we should be looking at how do we do it inside, in situ, without moving away. So we started with one of the drain that was coming inside our campus and leaving. So we were not contributing to this drain, but we were facing the negative aspect of this drain, and we started doing work on this. So this is how we created this place. The sewage will come, flow through, and then get out. So we converted this whole drain into a system which is worth walking around and looking at how a dirty drain can be treated. What it does is that we have a series of screens, coarse and fine screens to move floating matter. Then as we go ahead, we create sedimentation as well as anoxic chambers and systems. We use biomats which are immobilized with bacteria which are specific to the drain pollution that we have. Mostly this is sewage, so it's much more easier to do. And then we also do diffused air aeration based on the calculation that has happened from the previous units. After this, we get into a system which we call it phytotrap, which is a combination of bacteria immobilized on specific stone systems and also plants root systems, which grows into it. And in the final policing units, we have floating plants. We call it flow raft, and then it flows out from there. So what you see here from this on the left, on the right hand side, we get water, which is treated to a level which is acceptable. This we have been able to implement in many places. As you can see, some of them in Prayagraj, most of them. Now we are doing a few more in various parts of the country. What it does is that if we have input, which is in the range of about 80 to 100 milligram per liter, we can go down to 14 to 24. But if you want to do it even more, we need to do additional design for the whole thing. So depending upon how much space we have, how much flow that we have, what kind of shock load it is likely to have, this system can be customized. So if you can see some of the news article which came on this technology, which we did in Prayagraj, it was very well received. In fact, during the Kumbh Mela, this was a place where the maximum area was cordoned off for taking and for bathing purposes. And it was so clean that many people thought that it's a new stream of water which is flowing in. This is a picture of the place where the drain was getting treated and then coming out here. We have after that this is recent times, but before that we did 5 to 8 based rejuvenation of Karmu River, and we set it up 8 STPs of about 11.5 MMD capacity. Also Google Maps, what you see here as tagged, these are all 5 to 8 plants which have been able to take at various locations all the sewage which comes, gets treated and then gets discharged into the Karmu River. Some work that we did before, current Prayagraj Kumbh Mela way back in Godavari, where we treated wastewater which was going and frothing the whole system. We planted it and then we got a much cleaner place over there. Recent work which has been completed in terms of treatment, it has happened. Now the beautification part of Shahadra Lake is going on. Here we are treating sewage which is pumped from one location, about 3 MMD, 3 million liters per day. And that water is going to be used for rejuvenating Shahadra Lake, which has gone dry completely in recent times, and is likely to become an attractive place for people to again go. So this is where I'll stop. This is the place which I showed you in the beginning. This is our drain, which is what place going. And I would suggest that all our drains should look like this, so that people start making their houses. The front doors is on the side of the nala, not the backyard. And once we do that, we will be successful.
Thank you, Rakeshji. Thank you. Very interesting project. I remember 10 years ago when I started documenting your work, and we were happy to say that Mount has some of these case studies which you have done. Thank you. Mehreen, please take over. Till the time Mehreen starts off, may I request participants to post their questions in the question and answer section of the Zoom, and all the speakers, you can mention the question to whom it is directed, and the speakers will also keep answering before in the meantime before we open up for question answer session later at the end. So please put your questions in the question answer session in the icon below in the Zoom, and speakers can answer there also. Please, Mary.
After a PowerPoint presentation by Dr. Kumar, we have Mr. Jha, Indra Kant Jha. He's working as a technical head at SINE IIT Mumbai, incubated company Emergy Enviro. In 2013, he was appointed as the technical expert in the Technical Appraisal Committee of the Maharashtra Pollution Control Board. In addition, he's working as an environmental consultant for various corporate companies such as Aditya Birla Group and many more. He is associated as an environmental expert member with the Milla Bhayandar Municipal Corporation and MMRDA. So over to you, sir, for your presentation. I'm stop sharing my screen now. So Mr. Jha, over to you.
Thank you. Thank you, Dr. Mehreen. Thanks for the introduction, and thanks, Dr. Rohila, for this opportunity to speak and discuss about the technology. So I am sharing my screen now.
Yeah, please.
Hope it is visible to everyone.
Yeah. Full screen kar di.
Yes. So basically, I am going to discuss about IIT Bombay technology called as integrated wetland technology. So the content will be like basic fact about the sewage generation, treatment, and disposal, about the conventional technologies, then the IWT system, their detailing, finances, and the case study for Lonavala Municipal Council. At present, as per the CPCB report 2015, we are generating almost like 62,000 MLD of the sewage every day, and out of this 38% we are treating and 62% is untreated. Out of that 38% also like 50-60% of the installed system is in defunct state, not working very properly. There are several reasons for that. We'll discuss on that part also. And whatever we are not treating, that we are directly discharging into the natural water bodies. And that will lead to the deterioration and the pollution of the natural water body. So this is what a conventional treatment system looks like, consists of the preliminary, primary, secondary, tertiary, and the sludge management unit, followed by the treated water section. And there are like several questions like high electricity use, pumping requirement, high maintenance requirement, odor issue, high sludge quantity, mosquitoes, chemical requirement. These are the points that we will address with due course of time, gradually while discussing all this technology. And at the end of the integrated wetland technology, I am able to discuss on these points and give some kind of solution on this. So next is about the wetland technology, integrated wetland technology developed at IIT Powai. And this is what it looks like, consists of preliminary treatment section, primary treatment unit, secondary treatment, followed by disinfection, and finally the treated water. The best part in the USP is flow is completely gravity based, no energy is required for hydraulics, no chemical is required, maintenance is very minimal, and the flow is subsurface in nature. One section that is preliminary and primary is completely underground, followed by the secondary treatment system. This is on ground, whereas the flow hydraulic is subsurface. You are not able to visualize, you are not able to find it out or see how water is flowing here. And the other USP of this IIT Bombay technology is in the first time in the history of natural treatment system, there is a concept of solid retention time and the sludge management system. Because most of the cases, the failure of the natural system is mostly due to the chalking issue. And then the whole system is upset, then we need to clean the whole system. We at IIT Bombay start thinking about that part 10 years before, and then we come to this particular innovation. Let's have the technology that will take care of these things, that will able to address the issue that we are facing due to other natural treatment systems. So we'll discuss point wise. So this is what the preliminary treatment system looks like. Left hand side, this is for the conventional system and open to ambience in most of the time, whereas in IWT it is completely closed. This picture is from one of the sites that we have installed the system. And then this is the primary system. Primary system consists of primary solid removal tank, followed by sequential anaerobic buffer reactor, followed by biosequential filtration unit. Everything is underground and closed. Then we are coming, and this is the pictorial view, how it looks like. It is completely underground, and the whole space can be reused for some other purpose. And in the left side, you can see how the primary sedimentation or primary treatment unit of any conventional system looks like. Primary system is followed by the secondary, consists of static bed biofilm reactor, SBBR unit, and the sludge circulation unit, as well as we are maintaining the SRT. Of the secondary system is coming to the, this is how it looks like. And the left side, this is complete like the biological system, the aeration unit or basin of any conventional system. And the right hand side, this picture is from the installed plant at Nasik in Sandeep University. This is for 3.5 lakh liter of a day. And this is how it looks like. Completely like you can see on the top layer of this plant, it is completely dry. You are not able to see the water anywhere. It is flowing subsurface, and that has some added advantage. I will discuss about this in the coming slide. This is about the tertiary treatment and disinfection. We are also adopting this practice and making sure the treated water can be used for any of the secondary purpose. And if aesthetic allow, if people will allow, then we can add one more unit and make it as a drinking water quality standard. These are some of the points that we discussed in the conventional part about the energy. Here we are not using the energy. Energy is minimal, that is only for the filtration at the end. No energy is required for secondary, for primary, and for the sludge management as well. Sludge we are taking care once in a year. We are not withdrawing sludge every day. Second is no chemical. We are not using chemical. Aesthetic wise, it is very good. On a skill level, we don't need skill level. We don't need engineers. They will go and take care of all the big machine, mechanical equipment, blower and everything. No, not required. And one biggest conception about this kind of technology everywhere is people are saying its requirement is much on the higher side. No, it is completely misconception. In this technology, if you can see this very, very carefully, we can use 95% of the space. Whatever we are taking, we can use 95% of the space. Whereas in any of the conventional technology, we cannot use a single inch of the space from the treatment plant. In the system, if you have the preliminary and the primary completely underground, that space can be directly used for car parking, for the playing, for the walking, for any other purpose. You are not like completely occupied the space in the treatment only. Whereas the secondary, that looks like your garden area can be a part of your aesthetic. People can sit around, roam around, and enjoy the whole scenic value. They will not feel like this is the complete. We are dealing with the filth. We are dealing with the dirt. This is all about how we are. Third point is the flow. We are doing the whole flow is subsurface flow, and the unique part about this is most of the treatment plant is very much like affected by the variation in temperature. If temperature in winter is in the range of 0 to 5 or 10 degrees Celsius, that will affect the overall efficiency of the secondary system. That is the system driven by the microbes. Whereas in the system, we are providing insulation. The flow is subsurface, means we are taking care, like the flow is 30 centimeter below the top layer. That 30 centimeter is the cushion, providing the complete outside environment, either in the hard summer days or in the winter days. That is another USP of this thing. And last is the gravity. Flow is completely via gravity. No pumping is required. In most of the cases, what we are observing, I am working with the Madhya Pradesh government for the whole state as a technical expert in their sewage plant in one of the scheme. Where I have observed in most of the places, most of the places, there is an issue during the monsoon time. Pumping station is not working. The whole state is default condition for 4 to 5 months. Again, we have to revive the biological system. So here, no pumping is required. We are taking care of everything via gravity. This is how it looks like. This is a 3D model of the IIT Bombay technology. And we are able to achieve all the consented standard parameter either by the State Pollution Control Board or Central Pollution Control Board or the National Green Tribunal. And when we talk about the finances, just have a look on this part. In terms of capex, we are either having that same kind of like capex is almost equal or little bit lower to the conventional one, but the USP is the OPEX part. OPEX is 10 to 15% of any conventional technology. Here, the financial sustainability of this technology will like come into the picture. Like installing a project is not a very big task, but running the whole project for the down the line 15 to 30 years is a big task anywhere. So our USP here is whole operation maintenance is 15% of any of the conventional technology. That's because we are not using energy, no skilled manpower, no daily maintenance or daily taking care of the sludge part as well. So that is another USP of this. So if we are talking about per MLD cost in crore, so operation and maintenance cost for 5 years is 69 lakh rupees only. Whereas in most of the technology, it is about 4 crore rupees or more than this. That's the major difference. And that's the USP. That's the thing that will make the whole system financially sustainable. And in terms of return on investment, it looks like in 10.5 years, we'll get the ROI. And after that, the whole system will work for next 19 years. And the overall profit by the secondary users of the treated water is in the range of 12 to 15 crore. This is as per the standardized, like the format we have submitted to Maharashtra Jeevan Pradhikaran, and this is based on that calculation. And this is a small video of 1 minute that from a site. It will give you the essence of how the system is working. I will quickly go into this. This is the preliminary section where the filter screen unit is installed and the sewage, raw sewage is coming to this point.
Indraji, can you summarize it 1 minute more?
How many time? How much time? 1 minute?
1 or 2 minutes. Yeah, 1 minute.
Yeah, I'm going through this slide quickly now.
No problem.
This is the primary treatment system, completely underground. The whole space can be reused for any other purpose. This is your secondary bit. You just have a look on this, the top layer completely dry, no mosquito breeding, no fly, nothing, no odor issues, no smell. People are sitting around this thing in the evening, and they are utilizing the whole space and owning the space. I am coming to the treated water. This is the treated water. They are using complete treated water in their for flushing and gardening purpose. This is how it looks like. And I'm just going through the case study for Lonavala Municipal Council. In Lonavala Municipal Council, they have already proposed and finalized a treatment based on SBBR earlier. Then the Principal Secretary Mita Rajiv Lochan ma'am came to IIT and have a look on this technology. Say, okay, I will go for this now, and they scrap everything. Then we have decentralized the whole Lonavala and Khandala area into 8 different zones: Shani Mandir, Fadias, Badri Visal, Shivaji Park, and Rani Garden, Bhusi Village, and Ramnagar. And this is the site location, and this is how the treatment is proposed, and we are working there in this. I'm just going through the slide. And this is the project summary. Total capacity is 13.5 MLD there, and the whole Lonavala Khandala area is divided into 8 different zones in decentralized manner.
We will be able to share the presentation.
Best part about this, yeah, I will say this. The best part about this, earlier Lonavala have a centralized treatment system that is 10 kilometers from the city, and huge cost was there in pumping. And we have cut short everything. There is no pumping, no big main lines and nothing. Everything is decentralized there. And not only in Lonavala, we are working with 11 different councils and 7 different countries outside India as well. And we are working with different state governments and discussing on that. Next is, this is the letter from IIT Powai about the technology, and another letter is from Society of Innovation and Entrepreneurship, IIT Bombay. Thank you. Thanks, everyone.
Thank you, Indrakantji. Thank you for an interesting presentation. I would like to take this opportunity now to break the monotony of only presenters and asking a discussant to come here. So I have with me Mr. Tyagi, who is experienced technical expert who has worked with Delhi Jal Board. Tyagi ji, would you like to comment upon these two technologies and give some reflections here?
Definitely. Thank you, Mr. Rohila. Actually, we are the end user of this technology which has been described recently. We have tried the phytorate technology which has been explained by Mr. Rakesh from NEERI. And we have also used the decentralized wastewater treatment plant, which have been suggested by you in 2015 also. And that is functioning very well. And we have also tried the technology that is soil-based technology that was invented by IIT Mumbai also.
Yeah.
So that a small plant was installed at the Keshapur, and this technology, soil biotechnology, followed by the membrane biotechnology, both technology were used, and the treated water was as good as the drinking water. So as for my experience is concerned, the phytorate system which has been suggested by CSIR in 2015 is functioning very well at the headquarters Delhi Jal Board, and there is no maintenance cost in that plant. The only single HP pump is required to pump the clean water for horticulture purposes. And on the same basis, the constructed wetland system, I think, is also suggested by NEERI in various projects for rejuvenation of the water bodies, because no much electricity is required at these decentralized sewage treatment plants, and these are maintenance free almost. So Mr. Rakesh can comment more about this, because he has suggested many technology and in many.
I think it's good to hear from you, Tyagi, because you are from Delhi Jal Board, former Delhi Jal Board engineer member.
We are the end user also.
Yes. So very good for sharing your reflections with us. So I would come back to again, and thanks for giving us an opportunity to experiment and do a pilot project in Delhi Jal Board. And I'm happy to see that you are happy as an end user and a real beneficiary. So I think with this, I would move on to the next speaker. Marine, you can move on to the next speaker and request Indrakantji to stop sharing the screen. Yeah.
After the presentation on integrated wetland technology, we have another decentralized wastewater technology called soil biotechnology, chemist soil biotechnology rather. And for that, with us is Chandrasekhar Shankar. He's the CEO and director of Vision Earth Care, which is a sustainability startup incubated in Science at IIT Bombay. With his constant efforts, Vision Earth Care has been instrumental in setting up over 100 Camus SBT type water resource recovery plants, serving 1.75 million people nationwide, with a cumulative capacity of 145 MLD currently under implementation. Over to you, Chandrasekhar, for your interesting presentation. We are looking forward on the soil biotechnology. I'm just stopping my...
Right. I assume you can all hear me and my screen is available on your screen. Hello?
Yes.
Yes? Okay. So I'll just continue with this. So I'm going to primarily talk about CAMUS SBT, which is Continuous Advanced Multistage System using soil biotechnology. Soil biotechnology is a patent owned by IIT Bombay, and of course that was done in early 2000s. And since then we have done a huge number of improvements on it, especially in terms of reducing the footprint and improving quality and improving the operation and maintenance aspects of it. And that's what we call as CAMUS SBT. And it's basically a nature-based wastewater remediation. And I'm going to be showing case studies. And I'm also going to talk about a few other initiatives that we have started, especially after COVID, really got our creative juices flowing. So with that, let me go to the next. So basically CAMUS SBT, what do you get? On the top left, you can see a collage of plants, and that has been implemented across India. As of now, I think there are more than 100 plants approaching 145 MLD. A lot of governments have adopted it because of the low life cycle cost, the high quality treated water. We are recognized by multiple government agencies, MDWS, NEERI, CPHO. We've done a lot of work with MJP. We've done a lot of work with Karnataka. We're doing a lot of work with Gujarat. We're doing a lot of work with NES and Airports Authority and many other government organizations, along with private organizations. CSC has been kind enough to give us a platform, and we do support them at their AEPI NEERI facility in Rajasthan. So moving forward, the big advantages are that a lot of people think that we take up more space, but that's actually not true, as I think many of the other panelists have pointed out. 80% of the space utilized by nature-based technologies is green space. And as far as policy is concerned, we do not get credit for that. And I would actually request, the eminent attendees and also the panelists here to perhaps push this as a very needed policy push that you have to have green credits given to nature-based technologies, and they should be counted under the green space allocated to developers across the nation. So let me just move to the next slide. The initiative that we have started recently, inspired by the Citizen Salem Citizen Forum, Piyush Manush, has been also showcased by Down to Earth magazine. So essentially, they have rejuvenated a lake using these artificial islands created from the lake silt itself. It's something that we have proposed to multiple governments. We can do rejuvenation of lakes by using the wastewater that is entering the lakes and converting it into good water. So the picture here that you see is Aranya Dweep that will go inside the lake, made out of the lake silt. And then what you get out of this whole thing is the wastewater gets transformed into beautiful good water.
Chandrasekhar, there is no PowerPoint here. Would you want? I am not able to see.
You sure?
So it is there.
Yeah.
Yeah.
We are all able to see.
We are able to see.
Okay. With that, I hope Dr. Rohila, you've been able to fix it.
Yes, sure.
Yeah.
Yeah. Fix it.
All right. So this is a concept that we have proposed to multiple municipal corporations. We are hoping that in the next perhaps 6 months we should get a go ahead and showcase this pilot. Many of these activities are happening via Professor Shankar, who is the inventor of soil biotechnology. He's now a professor of eminence at Anna University. So some of these initiatives have now moved from IIT Bombay to Anna University, and you're welcome to get in touch with him moving forward. So the second part, the another initiative that we have taken is actually a lot of us are wastewater recycling people, but actually more important is the design of eco-cities. How do you design an integrated city that actually takes care of all these ecological and environmental problems, and rather than treating it as a waste to be moved out of the point of generation to a place far away, we are looking at it from the perspective of using it as a resource and converting the wastewater into valuable water that then creates water features and creates urban green islands, reduces urban heat effects. This is a concept that has been inspired by the colors of the peacock. You can see there's blue, there is green that represents the green infrastructure, there's silver around the sides. And when you network these, we have data that shows that we can get 10x the benefits over conventional cities in terms of water resilience, in terms of cooling loads, in terms of recreation spaces, in terms of happiness, in terms of many other aspects that most conventional cities have not done. And there's a concept that has already been floated out, and we are in the process of coming up with the first eco-city very soon. Hopefully, we'll get a builder or other organizations like MADA or the Prime Minister's Arogya Yojana and things like that will be clients for us. A new initiative that we have started with Pondicherry University is an initiative with which is similar to the floating wetlands concepts that have been mentioned before. So this is for in situ remediation of nalas. A few pilot projects are in progress. So once we have that, we will let all of you know on the progress. An interesting thing that we have put forward is actually persistent monitoring of water, lakes and rivers and nalas and drains, to see the quality, how it changes before and after intervention, or monitor the quality of the water as environment changes or human inputs change the water stream themselves. So interesting note that has come out, during lockdown, we were monitoring the Najafgarh drain in Gurgaon. So on March 23rd, the COD level at Najafgarh was at about 170. So as you can see, as the lockdowns continued, the COD levels in Najafgarh drain have actually reduced to about 48 and lower. So this is of course not due to any biological action, it's simply that the industries have shut down. But we are using this tool, this what's called as the floating online river monitoring or river effluent monitoring solution, as a method of process control to judge how well our nature-based interventions are functioning. Moving on, so I'll come to the piece de resistance, the CAMUS SBT process. What you're seeing here is a collage of various treatment plants that have been set up across India. This is a treatment plant. The top left is a treatment plant which is built into the road divider of a housing society. You can see people live less than 10 meters away from it, and as a lot of the other lists have pointed out, they do not consider these nature-based interventions as something to be hidden away. It is actually highlighted. It's a place actually the STP-facing flats have gone for a premium. So a lot of developers, they have actually when they start negotiating with us in terms of pricing of the solution, we actually point out to them that they are at the STP facing flat will actually go for a premium and more than pay for the cost of the technology. Of course, we would also request the eminent government authorities here to help recognize the greenery that is part of this process. And SBT itself doesn't require plantation. So this is a treatment plant in Nagpur, the one without any plantations in it. We use the soil biology for this. It is, it's not a flooded system like what has been explained, the phytorate and the IWT. So there are some significant differences in use cases. This is the plant. The one in the middle is a BMC plant that was implemented by IIT Bombay back in 2005. There was a 3 MLD pilot. The top left here is, I mean, just in the garden path that you see is Dev Prayag at the confluence of Bhagirathi Alaknanda that forms Ganga. So inlet and outlet. So the interesting thing here is that CAMS SBT actually does not require any tertiary treatment to achieve the NGT standards. We don't need sand filters. We don't need activated carbon filters. We get the treated water quality directly from the biological process. This is the top right is a very interesting plant that we have done. It's actually built into the compound wall of a colony, and the whole thing is completely outside the the use paths and things like that. So we are a technology partner for Maharashtra government and many others for the treatment. So we are doing a lot of projects in rural Maharashtra. Close to, I think, 25 plus plants are being implemented through MJP and also through the UD, Maharashtra Urban Development. And Maharashtra, we have done a lot of projects in military engineering services. Plants exist in Jaisalmer, in Koda, in Vizag, in Bangalore, and many other places.
Shekhar, 1 minute. One more minute.
I'll just finish up quickly. So this is the BMC plant. The left side is the 2005 picture. Right side actually has become a forest. It is still treating water, but you get this beautiful urban green zone that comes into the picture. This is the picture. This is Hirohalli plant. This is 1 MLT plant. And this is Pandharpur. We recently implemented this 2.5 MLT plant in Pandharpur for the Wari. So it handles 1.5 lakh population pilgrims. You can see left, right, the treatment quality. The outlet after PM2 is nearly equivalent to drinking water. And this is the picture at the time of commissioning, and this is the picture at the time of just now. I mean, actually, it was today's picture, so I thought I'll just integrate it. We've done it in Lodi Garden. You can go and visit. Jetli sir actually inaugurated this plant. He's unfortunately no longer with us. But this plant is providing treated water for all the irrigation purposes for Lodi Garden and also Nehru Park. So this is the 0.5 MLT plant. This is the Nagpur Improvement Trust plant. And so many more. I mean, we have done many plants, small cities, airports, and so on. So these are all pictures that we have. So with that, I will end my presentation. I hope that was interesting to all. And any questions, I'll be happy to answer.
Thank you, Chandrasekhar. Thank you for the presentation. We have some of these case studies also put up on the Mount. So people who are interested to know more, they can visit there also. There are questions like CapEx, OpEx, and all those stuff. So, and there are more every day. I keep on tracking Chandrasekhar. He keeps on inaugurating new projects in different parts of the country. So good to hear, Chandrasekhar. Again, thanks a lot. And there are technology specifics also mentioned on Mount. So please visit Mount. And once again, I request all the participants to post their questions in Q&A section and also mention the question to whom it is directed. And all the speakers are requested to take the questions over there before we open up for question and answer sessions toward the end. So now, Mehreen, we can move on to the next speaker, Ganpati.
Yes, it's my privilege to introduce the next speaker. Ganpati sir, he's the Director of Program, CDD Society, Bangalore. He's an infrastructure and sustainability professional who brings with him around 25 years of experience in the infrastructure sector, spanning water, sanitation, urban infrastructure. And at CDD Society, he drives strategic initiatives, outreach activities, and program management across sectors. Institutions like Wipro, Boda, IHS in the area of urban infrastructure, real estate, water, and sustainability. Over to you, sir.
Yeah, I'll share my screen.
Yes, you can.
Am I audible, by the way?
Yes, loud and clear, sir.
Okay, great. Can you see my screen?
Yes.
Thank you, Mary. Thank you, CSC, for the opportunity. And congratulations on Mount, as well as on the O&M. My presentation, while I will talk a little bit about CDD and DWATS, There are a lot of similarities between what various other people have presented. All of these are under a, you can call a basket, ecological approaches and decentralized approaches to wastewater treatment. While I'll tell you a little bit, because there are variations to all our approaches, I won't go too deep. I have sort of pitched my talk a little more on looking at the challenges and learnings that we need to take from here. So I'm not going to be showcasing a lot of our projects, but I'll be probably raising some questions for all of us to think about. But a brief introduction for those of you who don't know CDD. We were set up in 2005 as a nonprofit. We are about 50 to 75 engineers now working from Bangalore. And we have a network of more than 30 plus partners funded by various, the German government through BORDA, Bill and Melinda Gates Foundation, and so on. Our focus, the sectors that we work on is wastewater treatment and reuse, and our brand there is DWATS, which stands for Decentralized Wastewater Treatment. We are into water body rejuvenation and have been working on various projects for the last about 4 to 5 years. 8 lakes in Coimbatore, which is under implementation now under the Smart Cities program. We are working on the Mahadevpura Lake, Sadramangala Lake rejuvenation, Alapi Canal rejuvenation pilot, Saidpur Nala, and we also did some studies for Palan Drain in Delhi and so on. So we look at water body rejuvenation from a pollution mitigation perspective. We are into fecal sludge management with the well-known Devnali project as our first one, but we are currently about 15 fecal sludge treatment plants that we have implemented using the DWATS kind of approach across the country. And we also into waste management. More broadly, we integrate all our products and services under the umbrella of integrated urban water management. Our nature of services include technical solutions, capacity building, applied research and development, and knowledge, various kind of knowledge management and publications. And if you go to our website, cddindia.org, there's a lot of publications that might be of relevance and use to you, particularly two that we have recently loaded on water body rejuvenation. One called Approach to Water Body Rejuvenation. The other one is a compendium of various water body rejuvenation projects, which might be worth seeing. Plus, there are a lot of videos and other things on our projects and technologies. Now, for brief sort of introduction to DWATS, it's quite a simple process. It's fundamentally an anaerobic process. The primary module is just like a septic tank. We call it a settler. Main purpose is to sediment and settle the solids. The secondary module is an anaerobic baffle reactor with multiple chambers and anaerobic filters. And the next chamber is what we call an advanced secondary, or more in the category of tertiary treatment, which is largely horizontal flow constructed wetlands. And then as some kind of polishing, we can look at disinfection can be through a natural process like ponds. In the first slide, you saw a picture where you had a large wetland as well as next to it a polishing pond, or you can replace it with conventional chlorination and ozone disinfection systems. In terms of cumulative efficiency, based on input parameters, the removal efficiencies we get maybe around 30 to 40% at the settler, cumulatively around 75% at the next stage, which is the anaerobic baffle reactor and filter, close to 90% when it moves through the planted gravel filter, and post the polishing, we can look at somewhere close to 10 to 20 kind of milligrams per liter BOD. Why DWATS? Again, a lot of people have already highlighted some of those in the kind of technologies they have espoused. Very similar things here too. One, it's versatile. It is sort of applicable in various contexts, largely to treat domestic wastewater, ranging from, the sweet spot is somewhere between 10 kiloliters to about 100, 200 kiloliters per day, but we have gone as high as 1 million liters per day in the Mahadevpura Lake rejuvenation project, and that's been working for about 2 years now. We are also going on the lower side to look at household scale DWAT system, ranging from half to 1.5 cubic meters per day. And we have a very interesting project of trying to implement a variety of household scale systems as an experiment in the Kerala Institute of Local Administration. And then these are customizable, modular, and so on. Robust because it can take a whole range of inflow fluctuation, both hydraulic and organic loads, can work at as low as 20% loading also. which is a general problem in many aerobic kind of system. It's passive with no moving parts, no electromechanical systems. It's sort of self-governing in that sense. Low operations and maintenance, just a gardener is enough, part-time, not even full-time, and once in 2 to 3 years, desludging might be needed. And it's simple and efficient. Construction can be largely handed over to local masons by giving very little training and dissemination of the approach. And the anaerobic process produces very little sludge. And it's also, as some people highlighted, a sealed system. So although it occupies space, the top is completely usable for things like car parks, or you can use it like a stage. So there is really, other than the planted gravel filter, the wetland, the other one is completely covered. Next, we will, so this is a wide range of applications, and CDD has built or facilitated over, we would have done ourselves more than 100 to 200 systems, but through our partner network and other people who were, with whom we have trained and developed as entrepreneurs, more than 400 systems have been built all across the country in the last 15 years or so, across different kinds of applications, and I'll come to some of those later. Now I move to the section where this is where I really wanted to spend some time on what are the kind of challenges and learnings that are emerging, and I'll deal with it in the following 4 sections. Firstly, I think we've had a regime where discharge standards have been evolving, starting from up to 2015, where it was 30 BOD was sort of okay for releasing for discharge. We had the MOEF come up with a target of 10, which then got revised in 2017 as 20 for metro and 30 for non-metro. And now we have the NGT order in 2019, which brought it back to 10. And that seems to be a sort of a directive from CPCB to a lot of the state pollution control boards to again target 10 BOD, which is quite a challenge for most systems. Whatever people might claim as achievable, it is indeed quite a challenge. So up to 20, I think, is achievable. From moving from 20 to 10 is quite a journey. So we've been really trying to see how we can make the tertiary treatment process more efficient for ourselves. We have the planted gravel filter and the polishing pond, but that occupies a lot of space. The PGF, for example, occupies close to 65% of the area and accounts for about 45% of the cost. While it does a decent job, we are looking at systems that more like hybrid kind of systems, where we are trying to see how we can improve the efficiency while keeping our cost and space requirements low. So we have attempted the Vortex, which was developed in Auroville, Pondicherry, but we have implemented that in a few of our projects. We have looked at aeration tanks for small scale aerators. One of them is called the Eco2 aerator, sand carbon filters. And we also experimented in the larger context in lakes and water bodies with vertical flow wetlands and similar systems. And we are getting some interesting perspectives from all this experience. And I think going forward, we'll have better tertiary treatment modules, which are also passive, nature-based, but giving us much better efficiencies compared to the horizontal flow constructed wetlands, both in terms of space and cost. So and the classic sand carbon filter is also something that we have used regularly in all our projects as a tertiary treatment process. We also tried to innovate both in design and materials and construction. One of the, over the last 15 years, BORDA as well as CDD did some research on existing projects, and one of the realizations we had was we used to provide many chambers of anaerobic backfill reactors, but incremental removal after 3 chambers was found to be not cost efficient. So we have started keeping the number of backfill reactors to around 3, sometimes 4, depending on the requirement, and anaerobic filters accordingly. This has made our plants a little more compact. And we've also looked at how to moderate the peak flow through balancing tank arrangements, which will then require pump, but it gives us better process controls and bring the peak load down, allows us to reduce the cross-sectional area and footprint, but also may require us to go deep a little bit. For example, in this 1 million liters per day project, to have a lower footprint to handle that kind of volume, we have gone as far as 3.5 meters deep with a balancing tank and a distribution repartition chamber and a distribution channel to achieve that kind of compactness in a 1 million liters per day system. So with this, I think we are looking at the DWATS has been becoming more and more cost and space efficient over time. One area in terms of materials that we are closely looking at is the filter media itself, although it's probably around 3 to 4% of the cost, or maybe 5%. We do see it going up because all these things are getting more expensive. Cinder used to be a very cheap material, but today good quality cinder has also started costing a lot of money. Gravel, cinder, and these were the classic things we used to use in our filter media. Some of our network partners have started trying plastic-based media like corrugated plastic pipes, waste pipes which are broken or disposed pipes and so on, or plastic biomedia which is used in MBBR kind of systems. But again, there are pros and cons. We are looking at doing a lot of internal research work as well as applied research kind of work is going on to try other kinds of filter media. Coal, for example, but though getting good quality coal that doesn't disintegrate, it's not easy. But we have been attempting.
Can you summarize in one
project. Yeah, just a couple of minutes. Plastic, biomedia, coconut husk, broken tile, clay, all of this is being tried out, and a lot of interesting results on how we can try and make it more efficient. But these are at early stages of exploration right now within CDD, but these are the directions in which we are looking to innovate. We are also trying to look at widening the application where DWATS was conventionally applied largely to small network, small bore sewer and community scale network systems. But now we are looking at non-network scenarios like open channel flow, drains, grey water treatment, water body rejuvenation, and reuse for flushing, car washing, slaughterhouse where you have high organic loads, or pure grey water treatment where your organic loads are low, or percolate from planted drying beds or sludge drying beds from fecal sludge treatment plants, and so on and so forth. So there are a lot of new application areas that we are exploring. And all of that means that we have had to innovate in different areas. For example, sometimes it's in the preliminary or pre-treatment, screening and grit removal, like in the Mahadevpura Lake project. And when you talk of higher capacities, pumping with balancing tank arrangements and more compact design, things like that. Using biogas digesters where organic loads are high, looking at improved kind of septic tanks with baffle reactors and filters and so on. So these are the kind of range of innovations and research that CDD is doing for making the DWATS more widely sort of applicable in more and more different contexts. With that, I think I will stop. Thank you, and maybe take up some more during the questions. Time was very short to cover our experience, but I hope you had a good glimpse of what CDD does and kind of innovation.
Thank you, Ganpati. Once again, I would like to say that some of your projects have been uploaded on Mount, and as well as your website also is very informative to talk about that, what innovation you are doing in practice. So participants are requested to visit Mount as well as CDD's website. We have contact details of the implementers. I would like to hear, take this opportunity to ask Ashish Ganju, who is one of the discussants, to share his experience that, we had an opportunity to engage with him when he was working in Ayanagar, urban settlement, a dense urban settlement, whether people accept this kind of a solution and whether there is enough space available. Because Ganpati was saying that, they have been experimenting and trying to reduce the land footprint of these technologies. And how did it come up? Do people find that it is acceptable, and is the performance meeting the acceptance level of people surrounding communities are fine, or they're complaining about Mr. Ganju? So you can unmute yourself, please.
Hello.
Yes, you see, I'm not a scientist or a technologist, I'm an architect. And my basic interest in using these technologies was to improve the livability of a city. Our cities over the last 50 years have become extremely problematic places to live in for ordinary people. And therefore, and I found that living in what is called an unauthorized colony, which is a very densely built up urban environment with no environmental facilities, no sewage treatment at all, open drains carrying sewage along with other wastewater, was the kind of reality. So here, how can one improve the situation and without resources? Fortunately, after about 15 years of research into this, The issue here is how does the community improve its own living? Because the central systems which have been in use all across are actually a legacy of the 19th century. And in the 20th century, we found that our cities have not been able to cope with central drainage systems, and more attention has been given to public transport rather than public health. So here we have a case where with very little resources, we had to improve the drainage situation, the livability index, as it were, of this urban neighborhood, which is really a slum. So we had to work in this, and we found that the technique which was developed by the DRDO, the Defense Research Development Organization of the Government of India, for biodigestion. So we could design a biodigester which is small enough to be put under the road of a dense environment where the roads are no more than 3 and 4 meters wide. And a series of them could actually do the primary treatment and the secondary treatment, because there's no open space also available here. But there was a nearby open space where we could take the water very easily, because this is just wastewater after treatment, primary treatment. And then a reed bed could be constructed there, which is where CSE came in and helped us construct that reed bed to proper engineering specifications, where I am not an expert. And we have happened to have done it. So now we have a reed bed, which is the only visible part of the whole system, with wonderful flowers growing in them. People are terribly pleased to have a place where you only could see refuse and garbage being dumped in this open space, now has a large sort of flower bed. That's what it looks like to people. There is no odor or any.
We lost you, Manishwari. Ashishji, we lost your connection, I think. Seems to be a power cut or something, maybe, Marine. So
can we move to the next presentation then?
Okay, yeah, we will, and I will connect again with Ishwarji to share later on. So I think there's a connection problem.
Okay.
So we'll send a message to him. We would take this opportunity because seems to be there is a network issue and we lost Mr. Ashish Ganju in this. He'll reconnect again. And it's a very interesting experiment. I can say that he was towards concluding remarks. He was saying that the planted filter is next to a school where there was a village pond which was used for dumping solid waste. And the solid waste was a big nuisance. And now because of a planted filter being created, there is no odor. The secondary treatment. Yes, you're back again.
I'm back. My signal was giving me trouble.
No problem. So please, I was just concluding. Please share your last words on that.
So I believe that we have to apply more thinking to how do people actually make, because the system we've installed doesn't require any technical expertise to maintain it whatsoever. And people, we've worked with people from the beginning, and who allowed us to use their public space, which is the road. There's no other public space available, to put this system in. And so we found that instead of engineering expertise, which of course we need, we also need a community awareness and community build-up, community mobilization, working with the community. And I think this is where, as an architect, I had the advantage, because I work with communities all over the country, building projects. But here there was a question of a built-up, very dense slum neighborhood. And we could actually make a sewage system in it. A sewage system which also took care of wastewater, rainwater, and gave them a clean road surface. The end result, the only thing visible, as I said, is this wonderful flower bed, it appears to be. But it is actually giving them treated water, and that water can be recycled now. They're asking for it to be sent back to their households. This is the end result, really.
Thank you, Ashish. Thank you very much. I think this is the recent project which we have completed. I think we will be happy to share. There's a video which we would be putting up on Mount, or it is already there, I think, Marine.
It's already
and there is
there.
a project report also. So now I take this opportunity, Marine, to move on to the next speaker, and again reminding all the participants to put their questions directed to speakers on the section, and speakers can keep on answering. But after this presentation, I will open up floor for 15-20 minutes live question answer session.
Everybody, till now, we heard about the different decentralized wastewater treatment technologies, starting from piped to integrated wetland treatment, to CAMUS SBT, to TWATS. Now, let us look at decentralized wastewater treatment through governance lens, governance perspective. And for that, we have two speakers all the way from Switzerland, Mr. Philippe Raymond. He is the project manager at Vienna. And before that, he worked with EVAC for 9 years. His main expertise lies in the area of urban sanitation planning, especially fecal sludge management and scaling up of small-scale sewage treatment plants. He led the governance component of the 4S project in India. Along with him is the co-speaker, Mr. Lucas Ulrich. He's an independent consultant, gained 10 years of international sector experience through his work in numerous African and Asian countries such as Morocco, India, Mongolia, Nepal. He specializes in sanitation and wastewater management solutions. And from 2016 to 18, he also was involved in the 4S project based out of Bangalore. So over to you, Lucas and Raymond, for your presentation.
Lucas and Philip, please take your 18 minutes, which I've promised you. And I will request participants that we might run 5-10 minutes delay beyond the schedule. But please take your 18 minutes, two speakers, and we're looking forward to your presentation.
Thank you, Marin and Suresh, and thank you, CSE, for inviting us. So indeed, now we'll talk about the scaling up process of small-scale sewage treatment. As you know, in 2006, the Ministry of Environment and Forest prescribed small-scale sewage treatment plant for buildings with built-up areas of more than 20,000 square meters. So this led to the implementation of thousands of units. If we look at Bangalore only, it is estimated that 10 to 20% of the sanitation coverage is thanks to small-scale sewage treatment. So it is clear that every technology will work under certain conditions. But now the question is, like, what are those conditions? But also in a city like Bangalore and many others in India, how can you ensure that thousands of small-scale units can work on the long run in such cities? So that's what we investigated in the 4S project, and that's what we will present now. So in the first part, Lucas will tell you about the current situation and the project. And in the second part, I will discuss government arrangements that are needed to ensure performance of small-scale sewage treatment at scale. So now over to Lucas.
Thank you very much, Philip. So yeah, recognizing the growing role of small-scale sanitation in India, this research study was started in 2016, called Small-Scale Sanitation Scaling Up, or 4S, with the idea to do a field research on the performance of small-scale sewage treatment plants, SSTPs, in urban India, and to analyze also the success and failure factors for such systems. So we are talking about SSTPs, which are here for this research purpose defined to be in the range of 10 to 1,000 households, or serving a population producing 500 to 700 KLD or cubic meters per day of wastewater. The project was done in a partnership between IIT Madras, EAWAG, Borda, and CDD Society as main partners, among others, and funded by the Bill and Melinda Gates Foundation as the main donor, and also parts through the German Federal Ministry for Economic Cooperation and Development. The final goal of FOREST project was to develop evidence-based policy recommendations for the successful implementation and operation of such systems at scale. So the approach used combines an assessment of sanitation systems on the ground and analysis of governance aspects, as well as the general enabling environment. A combination of different methods was used, starting with desk-based landscape study. And we then really went to the field to do a field evaluation of small-scale sewage treatment plants, covering the entire spectrum in terms of the typical technologies used, sizes of systems, application contexts, etc. This included a basic assessment of 279 units across India, with focus a bit more on the southern states, including Tamil Nadu and Karnataka, because our project was located there also, and because of the large numbers of units in these areas. Second, we also did a performance analysis of 35 systems with detailed sampling campaigns. 4S also included the governance analysis, looking at the policies, regulations, stakeholders, and governance arrangements, and the financial analysis, studying life cycle costs of systems and the financial reasons for underperforming units. To give you a good background for the governance-related aspects that Philip is going to talk about, we will very briefly share some key results and insights which we got from our extensive field research on the ground. If you're interested in the detailed study findings, you can take a look at the very new publication called Technology Implementation and Operation of Small-Scale Sanitation in India, which is our newest report and can be downloaded from sandex.ch/4s. So what we found is that in India, there are probably more than 20,000 existing privately implemented, owned and operated systems, which are distributed across the country, but Karnataka as a pioneer state has a lot of systems, including Bengaluru, with about 4,000 plus systems possibly already installed. The majority are variation of conventional wastewater treatment technologies, but also the whole range of other available wastewater treatment technologies is used. A key benefit from all these systems is water reuse. We found that overall the reuse is already quite well implemented, but systems normally produce more treated water actually than what can actually be used on site. Currently, the policies have enabled the establishment of a capable private sector with technology solutions ready to be scaled up. Lastly, we found that actually any of the technologies studied have the potential to achieve quite stringent standards in terms of BOD, COD, and TSS if combined with the right post-treatment units and operated correctly. Now, besides these remarkable promising developments and insights, there are of course also significant challenges that the small-scale sanitation sector is facing. First of all, in terms of cost, we found that small-scale sanitation can be affordable, but technology and design decisions commonly neglect life cycle costs, impairing good operation maintenance and eventually also the performance. Secondly, we found that systems generally fail to meet nutrient and microbial parameters and often struggle even with BOD in practice. Another issue is the lack of a solution for sludge management. And then finally, overall, we can say that most units underperform in terms of several indicators and end up operating in an unsustainable way. So this includes unclear responsibilities, insufficient instruction and supervision of operators, insufficient maintenance funds, and also intermittent operation, among others. Now, the big questions that now arise based on this situation on the ground are first, how to explain the current challenges and what can actually be done. So if we manage to answer these questions, India can seize the promising potential of the ongoing scale-up process and achieve small-scale sanitation system in a sustainable way at scale. So let me ask these questions now to Philip: how to explain the current challenges and what can be done?
Thank you, Lucas. So what I will tell you from now on is encompassed in another recently published publication, where you will find the link now. So I recommend you, like, if you want more information, to refer to that one. So to answer this question about why the situation is so and why we have many underperforming systems, we started by looking at the whole project cycle. So as you know, like when you have to implement a small-scale sewage treatment plant, it's a whole process from the first idea to the long-term operation. So first of all, we have, of course, the planning, design, and implementation with a number of actors, the central actor being the real estate company. Then we have the operation and maintenance, which is managed by the building management body, often a residential welfare association or an outsourced company. And then during this whole process, we have a lot of interactions with governmental agencies, be it around the consent delivery, and then later on monitoring and sampling and monthly reporting. In that case, for the Karnataka State Pollution Control Board, as this figure is mainly focusing on the situation in Karnataka. So here, which kind of loopholes can we identify that may, in a later stage, lead to underperforming system? So first of all, we see that real estate companies are making technology choices which are often only driven on capital investment. So basically, they don't really care about life cycle cost and how much the residential welfare association we have to pay later on, provided that often this would be like a few years after planning and construction. Then there are issues with the expertise of the consultants building the systems, who often tend to try to fit a system within a small space instead of trying to build as that was planned. Later on, we observe that often the government agency human resources do not have enough skills and capacity to look in the details of designs during the consent to establish. And the same problem arises during the consent to operate. So there's not enough capacity to really go and inspect what has been built. Then there is the issue of the handover. As you know, buildings are built, sometimes take years to be filled. So between the moment it has been built, it can take years until the residential welfare association is created. And here there is an issue about the handover of skills for running the plant. Then you have the system about the laboratory sampling. So currently the managers are taking samples and then sending to laboratory, then it comes back. Of course, here, as you can imagine, it gives a lot of space for manipulation. Then you have the issue of archiving of all this data, and finally the capacity to run proper inspection in the long run. So all these aspects, basically, it boils down to capacities in terms of budget, human resources, in terms of monitoring and guidance. And all of this, basically, it goes to governance. So how can we explain the current shortcomings? Is that, for me, the main observation is this policy has come from the Ministry of environment, forest, and climate change. And it has been very successful to foster the development of a large small-scale sanitation market and the implementation of thousands of units. Unfortunately, since 2006, the market developed quicker than the necessary governance structures. So we have a lot of implementation, but unfortunately, still little monitoring capacity, and also a lack of integration by the Ministry of Housing and Urban Affairs and line agencies. So it still remains something from the Ministry of Environment, but unfortunately, it looks like it's not yet fully into the urban sanitation planning map of the Ministry of Housing. And this is to a key observation is that even decentralized small-scale systems also need centralized structures. By centralized structure, I mean structures for monitoring, structures for training, especially training of operators, troubleshooting, production of guidelines, information sharing, etc. So which governance structures can be put in place to tackle those issues? Well, we will recommend the development of two different structures. First of all, an online platform that would be collating all databases, streamlining and supporting processes from establishment to monitoring. Because right now there is not one single database where you can find all the small-scale sewage treatment plants across the city. So you have different small databases, and they are even not overlapping. So basically, there is no full overview. And secondly, we would recommend to create dedicated small-scale sanitation units at state and city level. So basically, small group of really experts of small-scale sewage treatment that can help the different stakeholders, and that will allow to concentrate the expertise into dedicated units. So quickly, talking about the features of such an online platform, basically it would be like a web platform where you will have system certification. So basically every unit would have its specific ID, would be geo-referenced. Then you would have all the information about consents, all the performance data history, so especially like all the laboratory analysis that the lab should directly upload and not sending via back and forth with the plant manager. A public interface to be able to exchange information and complaints, and a treated water marketplace where basically we can foster water reuse by connecting producers and consumers. And here we have the idea or the vision of an app, like an Uber app, that will link supply and demand of treated wastewater, knowing that small-scale sewage treatment is really a great opportunity for local water reuse. Now, the small-scale sanitation units, basically they should be at the different, in every state, and also like in every city. In every city, ideally it should be embedded into the water and sanitation, water and sewage board, sorry, or the urban local bodies, because they are the ones that are dealing with the overall wastewater management in the city. And all of this would also be linked with training centers where the operators, but also sanitation officers can be trained over the specific issues of small-scale sewage treatment. I would say that Karnataka should really play a pioneer role here because of the wide numbers of units they already have. And I think it would be the great opportunity for them to spearhead not only the development of the online platform, but also the development of a small-scale sewage treatment unit. So what are the benefits? Merging and completing of existing databases, the coordination between the governmental agencies, geolocalization and mapping of the treatment plants, simplify the administrative procedures through digitalization, great advantage for the users and private sector stakeholders, allowing automated prioritization of monitoring, and enabling learning through big data analysis. So which system works best and under which condition?
Just one more minute, Lucas.
Thank you. So this leads to the priority action. Basically, the first one will be to recognize the key role of small-scale wastewater treatment in urban city coverage, next to fecal sludge management and conventional storage, and also in citywide inclusive sanitation. Basically, finally, really put small-scale sewage treatment on the urban sanitation map, because it has become a very important system for increase of sanitation coverage. Clarify the roles and responsibilities, especially of the WSSBs and ULBs. Again, it can only work if all the systems are run and kind of planned by the same agencies. The production of technical specifications and guidelines for technology selection and O&M, such as already existing for conventional storage and being developed for fecal sludge management, and the development of this centralized online database. So to come back to this drawing to conclude, here you see in violet centralized storage, in orange fecal sludge management, and in green small-scale sewage treatment. This is the vision. Everything fits together and will contribute to 100% citizen coverage. And when we consider urban growth in India and water scarcity, the growing need for water reuse, we can realistically think that the curve would go like this through time. So small-scale sanitation will only take a bigger and bigger part into urban sanitation coverage. So I would like just ask Lucas for the last word about the follow-up.
Thank you very much. So if you're interested in further outcomes and publications of this project, you can check back on our website, sandec.ch/4s, or sign up your email address to be notified when something new comes out on the form indicated here as a link. And I will also post the link in the chat right now. Thank you very much.
Thank you.
Thank you very much, Lucas and Philip, for a very interesting assessment of governance and enabling frameworks which are required. I have a small modification to be done because one of our discussants had to go for a meeting which was urgently called up by the secretary. So Mr. Chaurasya is not around. So I'm asking for, and taking the liberty of being the moderator and anchor, to request maybe Tyagi-ji, would you like to say a few words to say that, you know, what are the learnings from EWAG research? How could we take this up further? And in India, how does the scaling up work? And also, if Rakesh Kumarji is still around, if you could also give us 2-3 minutes your reflections before I open up for the floor for question answer sessions.
Definitely, thank you, Rohila-ji. Basically, we have a lot of debate between the centralized system and the centralized system. In 1934, when the first plant at the Okhla was set up by the Britishers, it was set up with the objective that the entire sewage from the city should go out of the city. That is the off-site treatment. And a trunk sewer that is called interceptor sewer. Now it is ring road trunk sewer. It was laid from Old Fort up to the Maharani Bagh, and at Maharani Bagh it was pumped to the gravity duct, and then from gravity duct it was sent to the Okhla, so that the entire sewage is covered, and then it has no order for the public residing over there. So that was the objective of the Britishers, and we continue to follow that practice of the setting of the centralized sewage treatment plant till 1995. But when we face the difficulty, if any of the system in between on the centralized system, maybe trunk sewer or maybe pump house or maybe any component it is failed in between, the entire system fails. Then we thought we should go for the decentralized system, and then there was a paradigm shift in the Delhi Jal Board for setting up this decentralized sewage treatment plant instead of the centralized sewage treatment plant. And we prepared the Sewage Master Plan 2031 and proposed 76 decentralized sewage treatment plant of total 374 million gallon per day capacity. Now we are facing the difficulty because this Sewage Master Plan was prepared for the unauthorized regularized colonies or the illegal colonies. So we are facing the difficulty in getting the lands over there. because obtaining 76 plots for setting up the decentralized plant, it is very difficult, because in unsewered area, in unserved area, or you can say the unauthorized colonies, we don't have the land for even setting up of this small pump house also. So that is why we had to compromise between centralized and decentralized sewage treatment plant at some of the places, because where we could not find the place for setting up the sewage treatment plant, we made the clusters of some of the colonies, unauthorized colonies, and then where we could get the land, we are setting up those sewage treatment plant, combining the capacity of some 2 or 3 sewage treatment plants. Somewhere we got the land, and then we are setting up the sewage treatment plant. Now when we come to the technology for adopting the sewage treatment plant, it should be dependent on the type of use of the recycled water. If we are going to use the treated water for the irrigation purpose, then why should we go for the biofiltration? Why should we use the membrane biotechnology? Why should we go for the SBR technology? Because for irrigation purpose, we require 30 and 50. Somewhere we have the sewage treatment plant and giving the result BOD 30 and SS 50. But where use of treated effluent is for the polishing, we require for the cooling plant. So they are retreating the sewage, the treated effluent over there. So deciding the technology based on the use of treated effluent is more important than the other technologies. Number 2, the setting of the sewage treatment plant near habitation, it is very difficult, because if we get the land near the habitation, or for this decentralized sewage treatment plant, the people the residing over there, they don't allow for setting up the sewage treatment plant because of the odor, because they don't want to get these plants at near the habitation because of bad smell over there. We are facing the difficulty at Kondli phase 4. Entire Mayur Vihar is facing the odor problem, and they are objecting to it. They have even sent to Supreme Court for closing down this sewage treatment plant. So we should have the technology for deodorization. We have the technology in the market, but we should adopt at that point of time. Now coming to the DWAT system or the phytorid system, or you can say there are so many names for the constructed wetland system. You can name and you can get it patented from where you want. But the system is very, very commendable system is, and we are now have the experience at our Delhi Jal Board headquarters. Because Mr. Rohila, if you remember, you came with your team at the Jal Board headquarters, and there was an overflow of the sewage system nearby the headquarters. Then your team suggested for setting up of the decentralized sewage treatment plant, and we set up that because it was first kind of the sewage treatment plant that is called decentralized sewage treatment plant at the Delhi Jal Board headquarters, and now it is functioning very well. We had closed down 2 tube wells which were running and which were dry. There was no water for the horticulture purpose. But now, after setting up this sewage treatment plant, as per your technology, and you give the technical know-how for the entire setting up for the entire plant, now the entire water is being used for the horticulture purpose. BOD is coming at less than 20 and SS is less than 30. So this is a quality, and there is no smell over there. Even there is no maintenance cost, because once you grow the plant in the bed, so there is no need. Just you have to do the trimming only. So it is very good plant, and the second plant is being constructed at the Jal Vihar. So we have the good experience of such plant, but the limitation of these plants is that these can be constructed for the small capacity, not for the entire for the bigger plants. So this is my experience, which I shared with you. Thank you.
Thank you, Tagiji. I think we have also taken this approach, and we in this meeting we were trying to say that wherever possible, and as you see that today the national capital still has 35% of Delhi dependent on on-site systems. They have the right to have access to safe sanitation and treatment of wastewater, as the Ayanagar project has clearly shown. there could be surveys, there could be studies done, and if there are possibilities, then they should be provided with municipal systems which are economical and sustainable. And the study of Ayanagar and the pilot interventions shows the way forward in that regard. And this was supported by Delhi Slum Improvement Board. And we were able to find land within high density urban village, which we also say slum, but it is a high density urban village. And we were able to find some livability, what Professor Ganju says. So we have good experiences, and I see there are good experiences coming out of in this. I was trying to show you that, Bitush, are you around here, my colleague? Ministry of Housing and Urban Affairs has issued an advisory on site and off-site sewage treatment now. I wanted that if you could possibly open up and show it on the screen for people to have a look at that. Is it possible to have it a look? So with a strong advocacy and push for sewage treatment to be done at decentralized level, last month the ministry has issued this advisory which documents the guidelines which are available. Usually people say that whenever these projects used to come up, CPHU manual doesn't provide anything. We will not be able to do these projects. So there is an advisory which has been issued, and I think this is a good sign that there is a possibility of innovation in practice on the ground, and there are policy guidelines available. If there are planners, architects, engineers who want to take up these small scale projects for scaling up, certainly the EWAG findings need to be streamlined into the process of governance system and enabling framework. I would say that this is important. So I would like to open up the floor for now question and answers. So Mehreen, would you be able to and this this advisory is available on CSC website, and in chat box we can put up the link there, Vitush. And now I would like to request that people who have been writing the questions, if some of you want to have a question directed to the speaker, they can raise their hand, and Mehreen and Vitush, if you can pick up that speaker and open up the audio, and they can direct the questions to the speakers, and we'll take 10. I've requested the participants. I'll close it at 6:15. So 15 minutes delay, and kindly bear with me. So we will have 15 minutes question answer session before we close. So people can raise their hand, and Vitush and Mehreen, you can help me with this.
So it's Vitush, can you unmute the people who have raised their hands?
So there is one participant with the name Rohan Sunny. Maybe you want to ask your question? You can unmute yourself.
Yes, sir. Can you hear me, sir?
Yeah.
Okay, so it's just about my experience. I have worked for a forest project long back with Lucas and Philip from 2016 to 2018, and what I have seen in this DWAT system is the area consumption is so high. Hello, sir. Can you hear me, sir?
You have to just repeat your question again once.
Can you hear me, sir? British, sir, can you hear me, sir?
Yeah. Go on.
Okay, sir. Like I have worked previously for forest project from 2016 to 2018, and I have surveyed around 102 sites. And generally, some DWATs, most of them were DWAT sites. DWATs, what I see in this DWAT system, where PGF and wetlands there, it generally consumes lots of area. So generally, this system is not apt. It won't be apt in cities, in urban areas, no, sir. Generally.
Would any of the speakers would like to comment that? Because we have shown some examples within cities that it is possible and people have accepted it. Yeah, please.
I should take the question since he's talking about systems. I mean, if DWATS is being more generally used by decentralized systems, then that's a different thing. But since he said DWATS, I will take the question. So in my presentation, I did cover how we are looking at that. So wherever land is not that much of a constraint, like institutions and educational establishments and many other situations, like most people have shown, the constructed wetlands, although they occupy a lot of space, they also act like a garden next door. So in many cases people welcome that, and therefore it's not seen as eating away space. Secondly, even the primary and secondary modules are all sealed and under the ground, so the platform above that is usable for parking, and in some cases they even have a stage kind of thing and so on. So by and large, these spaces, while while the area occupied is large, it's mostly under the ground, or it's like a garden if it's a constructed wetland. And therefore, overall, it still actually doesn't consume space. But having said that, you still need that footprint to build and reduce that. Some of the alternatives to the horizontal constructed wetland that I presented in my presentation, the vortex and the aerators and so on, are ways by which we're reducing. And as the scale has gone up, we have also come to as low as 0.6 to 0.7 square meters per kiloliter when it comes to secondary module size. And the tertiary module depends on what, if you go for a hybrid kind of system, then it doesn't occupy much space. So based on the need and the context, we'll have to look at space. That's how I look at it.
So I can add to this something. We have been this is the second webinar. A month ago, we were doing the webinar on fecal sludge management, in which there was a submission by one of the members of NGT committee. Say, for example, Delhi is considered to be a very urbanized city, but there are 11,000 parks in Delhi, 11,000 open spaces where there is a scope for innovation, and the practice can be there. And you can find opportunities where this DWAT systems could be done. And for example, Delhi has already announced a policy saying they would be going for decentralized wastewater systems for local reuse for meeting horticulture water requirements. So there is enough space. You have to talk to the planners, architects who can tell you within the urban areas, planned areas, you may be able to find open spaces and public spaces which provide you an opportunity. Thank you. Vitush, you can take more questions.
I think Chandrasekhar wants to add something.
Unmute yourself, please.
Thank you. See, I think nature-based systems are actually eminently viable for wastewater recycling at any scale, whether it is decentralized or even large size. As Dr. He actually has mentioned, 0.6 to 1 square meter is what we want. And the conventional treatment system, I think they do not count it to the fact the sludge management and many of the other issues that are inherent with it. They basically take it and dump it out somewhere. The more important issue that I'm at least finding in the market is that a lot of government tenders, whether EJP or DDA or any other government tenders, the tender specifies technology as MBR or SBR. They actually do not have outcome-oriented tenders at all. So even if a nature-based technology is viable in that location, participation is denied. Even though the solution is extremely good, it will give better outcomes. The life cycle costs are lower, as Philippe have mentioned, and they have done some fantastic studies. This is actually well known. But for whatever reason, during the design DPR stage, when these tenders are being floated out, the technology is fixed as conventional aerated technologies. The technology still needs attention.
Okay, moving on, we have another participant who wants to ask. Dr. Rinku Jaiswal, would you unmute yourself and ask your question? Dr. Rinku Jaiswal.
Go to the next question.
Yeah, then we have another participant, Pradeep. Would you like to ask your question?
Unmute yourself, Pradeep. Pradeep, you have to unmute yourself.
Maybe I'll take it from the button.
Can you unmute him, Vitush, from?
Okay, we'll move on.
Okay.
We have Mr. Anup Kumar De. So please go on.
Hello.
Yeah.
Hello, am I audible?
Yes.
Yes.
Yeah, so actually my question is regarding the evaluation system. So is there any kind of valuation methods for waste water fed aquaculture, wastewater fed ecosystems like wetland ecosystem? if there is a centralized wastewater fed ecosystem is there, so how can I value the economic valuation? How can I go for that?
Anybody from the speakers like to take this? Economic evaluation of.
I mean, if you're just treating wastewater, I mean, the valuation is as what Lucas and the Boda team have done, is in terms of taking wastewater and converting into reasonable quality water so that it doesn't pollute or destroy drinking water sources or the environment. So I don't know if you can say there's an economic value to it as such, but yes, there is economic value, but the models are complicated. Nobody has, I don't think one has come up with a good method of valuing a wastewater treatment plant, for example, or a wetland, for example. I know it's easy.
Is there any other question?
Yep.
Raise hand.
Maybe I'll take one more. Hema Patel, would you like to ask your question? Unmute yourself and ask your question. Hema Patel.
If there is a problem with this side, then we can take from the question answer panel and then read out the name of the person and ask the speaker, because that's another way of doing it. Does it not work?
Okay. Shamla Mani, would you like to go ahead?
Yeah. Hi. I just had this question about heavy metals and chemical pollution. Very often, especially in illegal colonies, which Mr. Tyagi was also pointing out, there is a mixture of chemical and heavy metal pollution because of small-scale industries. So how do you deal with that? Because even if you remove it with root-based treatment, it will still be from the liquid phase to the solid phase. So, and just leaving it there will not be a solution. So how do you deal with that in decentralized systems?
Any of you would like to take up questions?
So we have done some plants in which we have taken Nala water, which is contaminated with industrial pollution. We do get the standards that is required, because even if there is industrial units nearby, very few of them, I mean, yes, there might be pharmaceutical and medical and things like that that are putting these waste into the water, but it's not on a regular basis. It's an economic cost to them also. So they don't really waste. I mean, there may be a small amount of wash water that is coming out of it, but it is getting diluted with a very large amount of sewage flows. And as long as the community is getting good water from the municipal authority, it is handleable, but it's not ideal. And most of the residual COD in the water that is treated is actually these recalcitrant molecules that are dangerous and does need some attention.
Am I unmuted? Yeah. So I just wanted to say that, one of my PhD students and we did an analysis of the situation in and around the Okhla land site, and we find that almost 5-kilometer area radius is contaminated with heavy metals, and the percentage is not very low. It is almost 100-200 times that of the standard. And currently the DJB is supplying tanker water to all these. There are almost 17 to 18 habitations there. They're all low economic areas. And groundwater is polluted. We took the DJB wells. In fact, the DJB itself has endorsed. In fact, they did the second testing. So it is there in all these places. And just now, the aquifer could also move towards South Delhi. I mean, we don't know where it is going just now, but it is there.
I think your observations are well defined, Shamla ji. I would also say that not every kind of waste is handled by DWAT systems or natural systems. I would accept that, and frankly, every system is designed for a particular kind of inlet load, what will come, and then we decide for the efficiency of the system in different modules. And certainly there are limitations, like an STP also sometimes may not be able to treat many of the kinds which waste which you are talking about. So we accept that, you know, there are situations where there may not be possibilities that, you know, DVAT system would work. But certainly DVAT system, we are not talking about for drinking water requirement. We could also explore non-potable water requirements which could be met from this. I would move on to the next question, Vitush. 1 or 2 minutes only, so maybe 1 or 2 questions more.
Maybe we can go outside the country. We have Mohammed from
Please ask them
Bangladesh.
to say the question to whom, which speaker it is, and to
Right.
have only question. Yeah.
Yeah, okay, thank you. This is Professor Gulam Murtuja from Bangladesh. I am the chairman of I am an ex-professor of Khulna University of Urban Planning.
Yeah.
And I actually chairman one urban plan development initiative in Bangladesh. I want to share two things. You know, it's a very good discussion. Well, I work on this the issue of the improved river system. I think river system has not been well taken. Maybe somebody has discussed. Well, I have two issues to be discussed here. One thing, I want to share the experiences of Bangladesh. Like, as you know, the cases of the India and Bangladesh is almost similar, but you are
Professor
ahead
Mohammed,
of
if you have a question, we would be able to have a question, because
I'm
we are
coming.
running out of time.
Yeah, I'm
So only
coming.
question,
Sorry.
I would accept it.
I'm coming. Well,
Please,
about
question.
the question. Okay. The problem of the wasting the water of the Buriganga, on the river, the Dhaka is situated. The water of the Buriganga is being polluted. Even the aquatic life is in danger. Not to speak about the taking bath and water for the household purposes. Okay, how to actually to mitigate this problem? Our government, NGOs, CBOs are trying, but nevertheless, we have some concerted effort. It's still not coming because of the social reason. Because our people do not understand the gravity of the problem. Actually,
So
how
I can answer that. We have been working, CSC has been working with WaterAid Bangladesh for over a decade or so. And
Right.
several of these DVAT systems which have been discussed today in the meeting, several of such systems have also been implemented in Bangladesh. We would be happy to, you know, guide you through and connect you to the right people. There's a community of practice of around 600 people who have been trained for planning and designing decentralized systems in Bangladesh. So you can contact me or my colleagues, Marine or Vitush, on this. The very last question, Vitush, if you want to take any question, the very last question.
Dr. Vinay Nikam, if you want to ask your question.
Yeah, this is Dr. Vinay Nikam. Yeah, this is Dr. Vinay Nikam. I have implemented a couple of DVAT system. It's possible to optimize the space by providing the sand filters and activated carbon filters and followed with a disinfectants. This is well good enough if we want to have a BOD up to 30. But now real challenge is that we need a BOD less than 10, because the current MOEF also they said that if you want to have a treated wastewater for the recycle and for the flushing and gardening, we should have a BOD less than 10. So this is specific question. Anyone from the DVATs, Boarda, because I have been implementing the DVATs, or Dr. Rakesh Kumar, you can please, because how to achieve a less than 10 BOD with this DVAT system is a challenge. This is my question. Thank you.
Ganpati, we can't hear you.
Can you hear me?
Yeah.
Yeah, so I brought this up. I hope we do have to look at hybrid.
Voice is low. Can you be a little louder?
Maybe I'll have to do this. Okay. Is it better now? Hello?
Yeah.
Yeah. Okay. Sorry for this. No, I did cover this a little bit, Dr. Vinay. So I did say that the tertiary treatment needs to be innovated. The classic PGF, the planted gravel filter or the horizontal flow constructed wetland with sand carbon filters is not allowing us to go, say it can take you to 20, maybe 15 in some cases, but not to 10 or below 10. Some form of aeration, I mean, if it's really below 10, honestly, at this point, we don't have an answer. We do think that some kind of membrane-based systems might be needed, or very large areas might be needed. We are exploring vertical filters, which seem to hold some promise, but even those, whether it can consistently go below 10 is a question mark. So in my view, below 10 is a real challenge for any system. And I have seen only membrane-based systems delivering that very consistently. And I rather would want to turn the question around to see why should we, I mean, Mr. Tyagi also touched upon it, as to looking at the end use, looking at the need, the standard should be fixed. To have a blanket standard of below 10 for any situation may not even be a desirable thing. So we have actually brought out a paper about 6-9 months ago to look at what should be the kind of discharge standards that are really needed, in a country like India and so on. Is 10 the right target to even have? So maybe you'll have to look at the question that way. Thank you.
I think it's a very right statement. Even the existing STPs which are there and which are not even performing to 30 BOD may not be able to meet these standards. So I would say that why to put the new technologies or small systems to that test, whereby even 30 BOD today, 80% of the sewage treatment plants in the country which are existing are not able to meet. So I would take this opportunity to thank all the speakers, all the discussants, participants, and the co-hosts of this webinar, Namami Gange, National Mission Clean Ganga, Swachh Bharat Mission team who have contributed to organization of this webinar. And there is a lot which goes in organizing such a meeting. At one point of time today, I saw that there were in this group 750 plus people attending, and this event was being live streamed, and people from 50 countries were watching this event. I would like to thank all of you who have contributed in this 1.5-2 months of preparations. Many people in this difficult, weird, new normal in which we live, we worked through it, and I think I'm very happy towards the end. I would like to thank all of you once again and say goodbye, stay safe, stay healthy, and let's remain in touch. And also, I would say keep contributing to the Mount, and we would like to keep this community of practice alive. And we would like to keep this momentum on, and we would come back to you with another set of webinar, which would have certain thematic, focused, targeted discussions in this area. Thank you very much. Have a good evening. Good night.
And thanks to CSC, Suresh and team for organizing this. Thank you so much.
Thanks, Marine, and thanks Rajat and Nidhi from Namami Gange. Thank you very much, all of you. And thanks, Lucas and Philip, for joining. I know by Indian Standard Time, we're 20 minutes delayed, and that's quite acceptable.
Thank you very much, Suresh, for organizing and inviting us to speak.
Thanks, Ashish ji. Thanks, participants, for all. Bitosh and Marine, thanks for all support. Always, Chandrasekhar.